Let's take a look at problem number 6. So in problem number 6, we're given a synthesis and we're told that there are some errors. And our job is to do a critical analysis, figure out where the errors are, figure out which reactions will work well and which ones will not. So let's take a look at each step and see what we can come up with. So the first step, alkene going to a secondary alcohol. All right, so when we look at this, we're adding an OH to the more substituted side of the alkene. And we look at the reagents that were given to do that. So this is oxymercuration, demercuration. All right, and it's useful to remember what the mechanism for this reaction looks like. So that we're going to end up with the aromatic ring over here. We're going to have mercury and again a partial bond so that we have partial positive and partial positive, right? So that we're going to get water to add to the more substituted side, which is where it ends up in the product. All right, so the regiochemistry of this is putting the OH on the more substituted side because of the mechanism. That's correct. We don't have to worry about stereochemistry in this problem. None is indicated. So this one's definitely going to work. So this is one we're going to want to write. Okay. All right, so first step down. Second step. We've got a Grignard reaction that we're doing here. So we're going to form that Grignard reaction, Grignard reagent, and then we're going to do a reaction with CO2. And we're going to form a carboxylic acid. So this is just like what some of you did in lab when you did the dry ice reaction when you formed phenyl Grignard. Right? So similar idea. Right? Form the Grignard, add the CO2, water, and you get the carboxylic acid. So this looks good. Right? So in the answer key, I wrote that this is okay. So if you look at the answers, this says okay. There actually is an important problem with this, and I think that when we did this last year, we may not have spoken as much about the problem in this one, right? But this reaction is not going to work, right? So if we think about what we know, this is not going to work. So this is an extra problem in the synthesis than the one noted in the answer key. And the problem is right here. We have an OH, right? And as we've mentioned several times, this is an acidic proton, right? And what's going to happen in this reaction is that we're going to form the Grignard reagent. That's not the problem. Right? But then we're going to have another molecule of the starting material. That proton is going to get deprotonated by the Grignard reagent, so that what we're actually going to form in this reaction, instead of a carbon-carbon bond, is a new carbon-hydrogen bond, and we're going to end up at O-. Right? And then when we add carbon dioxide, nothing's going to happen. All right, so this is an important point and definitely a mistake in the answer key just based on how we did this last year. All right, so this reaction's not going to work. It would just end up doing H substituting for the magnesium, and then you get the alcohol. All right, so you never form the carbon-carbon bond that you want. Okay, and again, when you do these types of problems, you write out what the problem was, but then you evaluate the next reaction without worrying about that it didn't work the first time. All right, so now we go back to what I've written down and see if this step works. Okay, so we want to look at what will happen when we treat the carboxylic acid with lithium aluminum hydride followed by an acid quench. And when we think about this reaction, right, we think about lithium aluminum hydride, and hopefully we remember that lithium aluminum hydride is incredibly powerful as a hydride reagent, and it's going to reduce the carbonyl all the way down to a primary alcohol. All right, so this one is not going to work. All right, so we won't form the aldehyde. All right, we don't have a reaction that will enable us to go from a carboxylic acid to an aldehyde. So that's a key point for us. If we did this reaction, what we would end up with is just having another alcohol here. So this would be a diol as a product instead of the aldehyde alcohol. All right. So again, just remembering what lithium aluminum hydride does when it reacts with a carboxylic acid. Okay, and if we move on to the next step, we're going to focus on transforming the aldehyde into an amine, right? And I know that we all are not huge fans of nitrogen chemistry, but I think we can work through this one. So we have catalytic acid, we have a secondary amine, remove water, sodium cyanoborohydride. This is the key reagent right here. When we see that, hopefully we recognize that this is going to be a reductive amination reaction. And in reductive amination reactions, we take an aldehyde or a ketone, some type of amine, we make an iminium ion and then add hydride. So if we're thinking about what's going to happen in this reaction, we're going to have the aromatic ring. We're going to end up forming that iminium ion if we work through the mechanism with the amine plus the aldehyde. And then when we have sodium cyanoborohydride around, the hydride reagent is going to add, and we're going to get to that amine. So that one works perfectly. That's an excellent reaction for us. That one's going to be okay, right? And now we're on to the final step, right? So in the final step, we're adding methyl lithium followed by an acid quench, and we end up adding a methyl group over here. So if we look at what's happening here, we have a hydrogen, and then it turns into a methyl group over here, right? And I hope that we can look at this and very quickly recognize there's no possible way that this reaction is going to work, right? When we have methyl lithium or methyl Grignard, we form carbon-carbon bonds by adding those to either carbonyls or epoxides. You cannot form a carbon-carbon bond by adding a Grignard or methyl lithium to an alcohol, right? There's no way for this to add and form a carbon-carbon bond. You already have a hydrogen in that position, right? What would happen if you ran this reaction is similar to what we mentioned up there for the Grignard reagent. You would do a deprotonation reaction so that you would end up just deprotonating the acidic proton on the alcohol, and you would get O-, and then when you added acid, you would end up just protonating that. So methyl lithium would get you here, and then add acid, and you would go straight back to what you started with by adding that proton back. Okay? So to summarize, we had 1, 2, 3, 4, 5 steps, right? And if we modify the answers that we had that I posted online, we had 2 steps that worked perfectly, and then we had 1, 2, 3 steps that had some problems with them, right? So hopefully this is helpful to think about these types of problems. Again, evaluate each step separately and then work your way through each step on their own.